Okay, some of you are going to find this to be review. You've probably done it before, but what we see is that you maybe are not as proficient at it as you really think you are. So I'm going to go through this pretty short lesson. Then I'm going to give you a worksheet to do in class for classwork, and then I'll give you homework. So this is about plotting points in the coordinate plane. How many have plotted points in the plane? You know what that means? Okay? So plotting points in the plane means you have two axes, right? The horizontal axis is called the x-axis. The vertical axis is called the y-axis. And then every point in the plane can be specified by giving the address, which is how far is it left and right from the middle? How far is it up and down from the middle? So a couple examples there. The one to the if you divide the plane up with the x and the y-axis, then you get 4 quadrants, and they are numbered. And what do you call that? Counterclockwise. Quadrant 1. Where's my pen? Quadrant 1 is in the top right, and then it goes counterclockwise. And they usually use Roman numerals for this, which I don't know why they do that, but they do. There it is. Okay, so this is the one which is quadrant 1, 2, 3, and 4. Okay, notice that when you put in parentheses 3, -2, the 3 represents where are you on the x scale. A positive 3 means you are to the right 3. The -2 says where are you on the y scale, and that means you're down 2. So this is 3, -2. Right? This one is -4, 0, right? Because it's 4 to the left, and it didn't go up or down, so it's still on the x-axis. Right. The point which is the middle of the graph, when you haven't gone up, down, left, or right, you're just plain in the middle, is 0, 0, and that's called the origin. Right? That can be a test question, like, what do you call that point? You're supposed to know. It's the origin. Okay. How far do these number lines go? Like the x-axis, how far does it keep going? I mean, does it stop at 7? How far does it go? Forever. It's infinite, right? And the same thing, this is going infinitely to the left, and it's going infinitely up and down. Okay, how do you make the symbol for infinity? Yeah, it's like an 8 that's laying down. So actually, to the right side of the graph is infinity. The left side of the graph is negative infinity. Right? Positive infinity, negative infinity. Right? So a lazy 8. So this coordinate plane, it may seem like just such a basic concept, but in fact it was invented in 1637 by a guy named René Descartes, and it revolutionized math and science. I mean, they knew all about, if you look at my poster right here, which is called Welcome to the Dark Labyrinth, this is a quote by Galileo. He's one of the most famous math scientists, ever. It says, "The universe stands continually open to our gaze, but it cannot be understood unless one first learns to comprehend the language and interpret the characters in which it is written. It is written in the language of mathematics, and its characters are triangles, circles, and other geometric figures without which it is humanly impossible to understand a single word of it." So when they described what mathematics is, it pretty much sounds like geometry. It's triangles, circles, and other geometric figures. But for, up until this point, it kind of was. That is what people considered to be a lot of what mathematics was. We could say that a circle, just describe it generally. A circle is the set of all points that are the same distance from a point, right? And what do we call that distance from the center point? It's called the radius. Okay, but when we came up with the coordinate plane, we could actually come up with an equation that involves x and y. Now we can describe it. It's x squared plus y squared equals r squared. And then we can study it. And so that's what started. Once Descartes came up with this, that's what's been going on in mathematics ever since, and a lot of the progress that's been made by Newton, by Einstein. It depended on this being done first, and it hadn't been done until then. Okay, So whenever we make these points like -4, 0 or 3, -2, those are called ordered pairs. Again, a vocabulary word that you could be quizzed on. It's called an ordered pair, and it's an address. You know, where am I relative to the middle of the graph? I used to live in Utah, in a couple different towns in Utah. And Utah, because it was settled kind of late compared with the rest of the country, you know, they did things like make their streets wide. Like in the east, a lot of the streets in the main cities are kind of narrow, winding kind of things. Also, you know, if you go to countries like Italy and that's what you find. But over there, they were able to make everything really, you know, well planned. And the cities that I lived in, like the first one was called Logan, Utah, which is in the north. It's the home of Utah State University, it's a really beautiful place. But almost all the cities out there are designed the same way, right? This one is always called Main Street. This one is always called Center Street. And then all of these streets are called, you know, this one is called 100 East. Right? This is called 200 East. This one is called 300 East. Right? Then these streets, this is called 100 North. This is 200 North. This is 300 North, right? And it goes all directions like that. So your address was always something like, my address when I lived there was 135 West, 800 North. Okay, well, given this, you know exactly where that is. Like, nobody has to give you directions to my house. 135 will go 8 blocks north, turn left, it's a little more than a block. And it was because I'd lived in a lot of places up to then. And those days, you know, you'd have to go set up all your utilities and your subscriptions of the newspapers. And it was mostly like going to offices and doing stuff, you know, but going to a place like this, it was a piece of cake, right? Because you knew exactly where you're going, every office. Now, these days we got Google Maps and, you know, and GPS, not a big deal. But that was you know, really made it easy. And it's essentially, what did they do? They made a grid. You know, they just made every city's a grid. Okay, so now let's give the coordinates of each point. Okay, let's look at this. What are the coordinates of A? Okay, now when you're given the coordinates of the point, you're not going to get full credit unless you put them in parentheses. It's a point. It needs to be in parentheses. So this one is -3, -3, +4. Okay, do you see that? It goes 3 to the left, 4 up. Okay, how about B? 2, -3. C? 0, 2. How about D? 3, 1. And E? -2, -3. Okay? So tell me, what quadrant is A in? 2. Remember, it starts up here and it goes around counterclockwise. Okay, so what quadrant is B in? What quadrant is C in? It's not in a quadrant. Okay, if it's laying on the axis, then you don't say it's in the quadrant. You just say it's on the axis between quadrants 1 and 2. Okay. I mean, that'll come up. There'll be a question like that. 7. So plot the points. Okay, which quadrant am I going to plot A in? -4, +4 puts it in 2. Right? That's A. Okay, which quadrant am I going to put B in? Okay, it's got X is positive, Y is negative. That's to the right and down. There's B. And what about C? It's right here in between 3 and 4. Okay. Easy stuff, right? Okay, name the quadrants. Oh, we just did that in the course of doing that. Okay, so now we dealt with this a little bit in the end of chapter 1, where they would give us an equation, and then we would substitute values for X, and then calculate the values for Y. Do you remember, what do we call the set of all the X values? The domain, right? And what do you call the set of all the Y values? is called the range. Okay, so they said in this problem, it says, graph the function y equals 2x minus 1 with a domain of -2, -1, 0, 1, and 2. So only those 5 points, right? It doesn't tell you graph those 5 points and connect them with a line. We're not doing that yet, right? All we're doing is graphing these 5 points. Okay, how am I going to figure out the y values that go with each one of those x values? Plug in for x, right? In this equation right here, y equals 2x minus 1. So let's see. 2 times -2 minus 1 would be, and you guys got calculators for this if you need it, -5. Okay, what would be 2 times -1 minus 1? -3. How about 2 times 0 minus 1? Okay, do you see a pattern here? How are these y values changing? You keep adding 2, okay? There's a reason for that. Okay, 2 times 1 minus 1 is 1, and 2 times 2 minus 1 is 3. So 1 and 3. So they gave us the x values, we calculated the y values. The set of all those y values is the range. Okay, when you're looking at a table of values like that, how do you know whether it represents a function? We did this before. Adam? If it had no x values, repeat. And of course they didn't, because they told us these 5 individual x values. It's a function. Okay. So now if we're going to graph those, right, from the table of values, I'm going to graph those. So let's see, -2, -5 should be about right there. -1, -3. 0, -1, 0, 1, 1, and 2, 3. Okay, that's the graph. So don't try to connect them with a line. If they give you a domain of just a certain set of numbers, then you just draw the points and you're done. Okay. What time is it? 9:31. Okay. So let's try to do the same thing with that. You try. Make yourself a graph. What did you say was the value of y when x equals -6?
It's 4.
Yeah, it should be 4. Remember, negative times negative makes positive, and then that's 2 plus 2 is 4. Okay. How about negative, if x is -3, y is 3. If x is 0, y is 2. If x is 3, y is 1. And if x is 6, y is 0. So we graph all these points. -6, +4. Can't read this very well. I think it's right there. -3, it's like this. So again, the x values are the domain, the y values are the range. And it's just those points. So how many is this like totally familiar? You're 100% confident? Okay. Well, then here's your classwork to get done. You're writing on this. Spot the points, connect them with a line.